This is another question on a quadratic sequence. They've given us a set of numbers. Now, they're not asking us to find the quadratic equation that these numbers are generated by. They're just asking for the next two terms in the series. So I'm going to show you a quick and easy way to do this. It's only worth 2 marks, so it's worth knowing that you don't have to go through all that rigmarole of finding the complete quadratic equation. This method still requires you to work out the first common difference. So I'm going to put our two numbers here, the two extra numbers that we need to know in the series. So 12 up to 17 is a difference of 5. 17 to 24, a difference of 7. 24 to 33, a difference of 9. So I'm expecting this to be a difference of 11 and this to be a difference of 13. 33 plus 11 is 44. And 44 plus 13 is 57. And these are the two answers that the question wants. So now for an exercise, let's work out the quadratic equation that these numbers are generated from. To do that, we need the next difference, which we hope, if it's a quadratic sequence, will be the same. And you can see it will be. And it's a difference of 2. So let's mark this line as the original sequence. Now, given the fact that we've got a second common difference of 2, n squared is the quadratic term. Let's also pop in our columns. This is n is equal to 1, and so on. Okay, I'm now going to calculate the values that n squared generates just from the fact that if n is 1, n is 2, n is 3. So this is, if n is 1, n squared is 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. And 5 squared, 25. So if I take the n squared element away from the original series, what am I left with? What I'm left with is the linear portion of the quadratic equation, which is bn plus c. So let's just do this. 1 from 12 is 11. 4 from 17, 13. 9 from 24, 15. 16 from 33, 17. And that's enough. I think you can see that if we now do the difference again on those numbers, we've got a common difference yet again of 2. Now, the fact that we get a common difference of 2 means that b is equal to 2. So our series is based on something like 2n. But we still don't know the value of c. To do that, we need to examine what do we get from 2n when n is equal to 1. Well, if n is equal to 1, I only get 2. But we need the value of 11. So c is 9. So our general term for un is n squared plus 2n plus 9. Now that should be the answer, but it's worth checking. Let's check n is equal to 3. We should get a value of 24 from this. u3 equals 3 squared is 9 plus 2 times 3 is 6 plus 9. Well, that's 18 plus 6. Yes, it does equal 24. So I'm confident that un is given by n squared plus 2n plus 9. And that's your extra answer.